This is problem 3 from practice quiz 8, and I'm going to read the problem. An elementary school tries to increase the number of fruits and vegetables that students eat on a daily basis. The school develops a program to educate students about the benefits of eating more fruits and vegetables. The school tests the program by selecting 5 fifth graders. Before starting the program, these fifth graders are asked how many fruits and vegetables they eat per day. After participating in the program for a week, they are then asked to report how many fruits and vegetables they now eat per day. And over here, I have provided the data. And part A states calculate the MD and the SD. And here I'm using small d because on this program I cannot make a large d, so I'll just be using d here. So the first thing I'm going to need to do for this is I'm going to have to create a d column. And my d column essentially takes my x2, which is my after, and subtracts my x1. So really what I have is x2 minus x1 to calculate my d. So I have 5 individuals here, so for each I have to do this. So the first one I have is 6 minus 1. And 6 minus 1 gives me 5. Then I have 10 minus 10. 10 minus 2, that gives me 8. I have 3 minus 0, 3. 5 minus 5, 0. And 6 minus 2, 4. So the first thing I want to calculate is my MD. And my MD is sigma d divided by n. And sigma d I get by adding my d column together. And sigma d is 20. And my n, there's 5 fifth graders, so my n is 5. So here I get an MD of 4. So I'm going to keep track of that information up here. The next thing the problem wants me to calculate is the standard deviation, but to do that I have to go through the steps. The first thing I'm going to have to calculate is my sum of squares for d. And to do that I'm going to first subtract the m from each of these. So I will have minus 4, minus 4, minus 4, minus 4, and minus 4. So 5 minus 4 is 1. 8 minus 4 is 4. 3 minus 4 is negative 1. 0 minus 4 is negative 4. And 4 minus 4 is 0. The next thing I'm going to do is square root each of these. And so my 1 squared is 1. 4 squared is 16. Negative 1 squared is 1. Negative 4 squared is 16. And 0 squared is 0. Then I'm going to add these to get my sum of squares. And I get 34. And that is my SS of D. So I'll write this here. Now I want to calculate my variance, my SD2. S2D. And so to calculate that I am doing SS of D over my DF of D. And my SSD is 34. My DF is n minus 1, in this case 5 minus 1, so then I have 4. And this gives me 8.5. And again, I'll write it up here. The last thing I want to do is calculate my SD. And to do that, my SD, I just square root my variance. And so when I square root 8.5, I should get 2.9. So I will go ahead and write 2.9. And so here I have my MD and my SD. The next parts of the problem states, conduct a 2 related samples t-test to find if the program made a statistically significant increase. Use an alpha level of 0.05. And B asks, should this be a 1-tail test or a 2-tail test? And to answer this, we have to see if the direction is provided to us. And it is increase. Sorry about that. increase is in fact a direction, and so we'll use a one-tail in the question, which is asking why. We just say because the researcher is looking for a specific direction, in this case increase. So therefore, C, when it says write the null and alternative hypothesis, we will have to use the symbols less than and greater than to write these. So let me start with the, because this is a one-tail test, I'm actually going to start with my alternative first. My alternative is always H1 colon. And here I'm talking about mu D, no need to mention the treatment. And my alternative always goes along with my direction, which in this case is increase. So if I were to increase from 0, my mu D would be greater than 0, because it would be an increase from 0. And now to write my null, I just flipped that sign around, and I'll say H0 colon mu D is less than or equal to 0, so that it won't increase. Null is always the opposite. Finally, D asks, determine whether you should reject or retain the null. Show your work. So to do this, I will have to see where my D's T lands on a T graph. So I'm going to go ahead and start with step 2. To find alphas T and to shade the critical region. So to find alphas T, I need the alpha, df, and the number of tails. So my alpha, as stated in the problem, is 0.05. My df, we had 5 individuals, so I take away 1 and I have 4. And my number of tails, as we decided, it should be 1. So given this following given criteria, I should be able to look up alphas T. Alphas T then is 2.132, and in this case, because I am interested in an increase, it is only positive. So now I'm going to create a graph here, and I'm only going to locate that positive 2.132, and I'm going to shade the critical region. I should only have 1. Step 3 then, I will calculate 3 things. I'm going to calculate SMD, and then I'm going to calculate DT. So SMD is the SD over the square root of n. My SD is 2.9, and the square root of 5, I had 5 kids. So now I have 2.9 divided by 2.24, and this equals 1.29. So this here is my SMD. Next I'm going to calculate D's T, and I'm going to use MD minus the mu D over SMD. My MD we calculated to be 4. My mu D is always 0 for this type of test, and my SMD is 1.29. And this comes out to 3.1. And here I got a different D's T than I wrote on the answer. On the answer sheet I wrote 3.08. The difference is just due to rounding, and you don't need to worry too much about that. You wouldn't get it as wrong. Finally, step 4 is to locate D's T and finally write the notation for the answer. And so I'm going to locate D's T in blue, and 3.1 would be somewhere there. That's D's T of 3.1, and in this case it falls in the critical region. And I can go ahead and write the notation as T4 for my DF equals 3.1 and P is less than 0.05. And the question says determine whether you should reject or retain the null. In this case, I am rejecting the null as it falls in my alternative area. And I will, and it did not fall in my null area. My null area being the normal area. So I reject it and keep the alternative.